Alrighty, folks, we're going to be talking about interior angle sums today. So we're going to start off with our first polygon, which is a triangle. A triangle has three sides, and we have one triangle and a triangle. We should remember from our previous unit on triangles that the interior angle sum of a triangle, or all three angles in a triangle, do add up to 180 degrees. Now, our next polygon is our quadrilateral. So what we can do is we can see how many triangles fit into a quadrilateral. When we do this, we're going to be drawing diagonals. So when I draw a diagonal, I'm drawing from any point on my quadrilateral to an angle that is not right next to it. So for this quadrilateral, I can only draw in one diagonal because if I go from E to F, that's just a side of the shape. And if I go from E to D, that's just a side. The diagonals kind of go across the shape to other angles that are not right next to it. So this four-sided polygon, or this quadrilateral, I can make two triangles out of it. So I'm going to put two triangles there. Now, at 180 degrees each, I have two of them. So if I do 2 times 180, or if I do 180 plus 180, I do get 360 degrees. Now my pentagon, I'm going to draw in my diagonals for my pentagon. So I go from I, that looks like, I don't know what letter that is because it's hiding, and then from I to K. So again, J and H are right next to I, so they aren't going to work for diagonals. They're just the sides. So my pentagon, I can create three triangles. And if I do 180 times 3, I would get 540. Or if I think about just adding 180 to 360 degrees, I would also get 540. Assuming I did that arithmetic in my head correctly. For a hexagon, so if I look up here, 3 sides gave me 1 triangle, 4 sides gave me 2, 5 sides gave me 3, 6 sides, I'm guessing is going to give me 4 triangles, but let's double check that. If I draw in my diagonals, again, I'm only going to the angles that are opposite or across the way. And I'm starting back here at the same point every single time. So I have 1, 2, 3, 4 triangles in a hexagon. So if I do 4 times 180, or do 540 plus 180 again, I'm going to go to Desmos just to double check this because you know me and my arithmetic, it's not very good. So if I do 180 times 4, I do get 720. Now, if we notice, there is a pattern with the number of sides versus the number of triangles that we are creating. So if you notice, like 1 is 2 less than 3, 2 is 2 less than 4, 3 is 2 less than 5, 4 is 2 less than 6. So to figure out the number of triangles from a heptagon or a 7-sided figure, if I do figure out what number is 2 less than 7, 7 minus 2 is just going to give me 5. So then I can either add another 180 degrees because I'm adding another triangle, or I can do 5 times 180. So if I go back to Desmos, do 5 times 180, I get 900 degrees in a heptagon. Alrighty, if I scroll down here a little bit, based on our data on our table, the number of triangles is just going to be our n minus 2. It's the number of sides minus 2 triangles. And then we just take that number of triangles and we multiply it by 180. So the formula that we officially use is n minus 2 times 180, where n is your number of sides of a polygon. Remember, though, in our class, I always like to double check to make sure that you understand why we have the formulas that we have. So when we draw on our diagonals, we can figure out how many triangles would fit into the polygon. And the number of triangles is always going to be 2 less than the number of sides we have. 180 degrees is the angle sum for a triangle. So we just take that number of triangles and multiply it by 180 degrees.